What is scalability with respect to system design? I like to think that scalability represents a system's capability to handle growth or handle growing amount of work gracefully, right? I use the term gracefully because in today's digital space, a small project that you just built over the weekend, one influencer or one very popular person with 2 million followers can post it and it would start to gain 200,000 users in it overnight, right? And so, how do you build that system for scalability? Not that in a situation where an explosion happens overnight, you can cater to those users and everybody that comes on that platform don't have a wonky experience. Wonky experience in the sense that they don't have an experience that is tumultuous. Like some people are trying to log in, they can't log in, they can't complete a payment, they can't complete just a sign in, the app is crashing, right? So when you think about scalability in terms of system design, and for you to build like a truly scalable system, right? You need to sort of build a system that serves more users or more processes without the system experiencing any form of degradation. So the goal for your system design with respect to scalability not is not just growth, is how can you gracefully grow, right? Where you are adding like features or capacity and it doesn't require any fundamental redesigning of your system, right? So, again, like I said, why does this really matter? Because things can basically change overnight. Sometimes it might be an influencer, sometimes it can be your marketing team. Your marketing team simply just goes out there, everybody loves your product, everybody starts to use your product, and then like it needs to scale to be able to cater to those new users their needs, right? So it does not your system does not crash, it doesn't slow down and start crawling and things of that nature. So how do you mitigate against this? Number one is to plan ahead, right? So you want to incorporate scalability at the heart of your design to reduce any retrofitting of your system later on. So from the start, um, I'm not saying that you should over-engineer your system. I'm saying just be thinking about how to vertically or horizontally scale your system, or even both, right? And I'll talk about vertically scaling and horizontally scaling in a bit. But when you think about it, you want to ask yourself what components might become a bottleneck over time. By bottleneck, I mean these components are they reusable, right? How much use cases would bring about the use of this component, and you need to start asking those questions from the start, and they would sort of inform your design later on. I did speak about vertical and horizontal scaling, but let me sort of define these two different cases, right? Vertical scaling is essentially scaling up. Now, this is a system, this is sort of like a process where you are increasing your capacity by upgrading to more powerful machines. So that is like faster CPUs, more RAM, better storage, things of that nature. So the approach is to simply just move your architecture or to sort of like increase your usage capacity, right? But this is a bit different from horizontally scaling, which is horizontally scaling, scaling up or scaling out, sorry. So vertical scaling is scaling up, horizontal scaling is scaling out. That's the key difference. Now, what does horizontal scaling represent? It's where you add more machines to your system rather than making your existing systems bigger. So, vertical scaling, the core difference here is you are making your RAM size bigger. You are increasing your storage. You are sort of going for a higher CPU, right? But horizontal scaling is you are adding more machines, right? So before now, maybe you had one machine. The next time for horizontal scaling, you're adding two more, you're adding three more, you're adding four more. But with vertical scaling, you are sort of like just increasing the power of maybe that one machine, for example. So you are increasing the CPU strength, you're increasing the RAM size, you're increasing the storage. Do you see what I'm saying? So for horizontal scaling, instead of you having like one powerful server, you're having like two, you're having like 10, you're having like 20, all of them working in parallel, right? So let me give you an example. With horizontal scale, you have large scale systems like your Netflix, right? Your Amazon, your Google, right? They run on many servers, right? Just not just maybe like they're not they're not few supercomputers, but then they run on like many commodity servers. So it's sort of like because of the power that it sort of needs, right? When you think about the capacity of Netflix, when you think about the capacity of Amazon and how many users they have, you would note that they might not really be doing much with vertically scaling. They'll be doing more with horizontally scaling because they need more power. They need to extend their systems a lot more. They need to do more. They need to even probably even have the highest level of storage, the highest level of RAM size. They have to have the highest level of CPU, the fastest CPU, because the reality is they have billions of users all over the world. Look at the Netflix, for example. Netflix has they're acquiring Warner Brothers, and that what that means for Netflix is they're going to, yeah, right. They're acquiring Warner Brothers, and reality is, what does that mean for them? It means that they're going to add HBO, HBO Max, HBO. They're going to add all of those shows that we always watch from HBO, HBO Max, like in Game of Thrones. They're going to add them to Netflix. They are going to add like some of your some of those those Warner products, right? Those your, I believe they're Marvel and the rest, right? They're going to add them. So pretty much like you're looking at a situation where Netflix becomes a conglomerate of its own, right? And with respect to this, right, in that situation, they they need like commodity servers to be able to serve their user base because now they're acquiring all those subscribers from HBO, HBO Max subscribers, all coming to Netflix, right? So before, if you had two subscriptions, you now have one, right? And those people that they didn't probably have Netflix before and they only had HBO, they now join in. What does that mean? That it becomes a humongous thing, right? And in this case, they need to be able to horizontally scale out. That is, they need bigger machines to be able to like take on this capacity that they need to take on. So um one thing to note here is that horizontally scaling offers nearly unlimited capacity and natural redundancy. So if one machine fails, the other will continue operating, right? So think about this practical strategy. Early in a system's life, right? Vertical scaling, so that is like upgrading to a larger virtual machine or a bigger instance would often suffice, right? And it produces that quick capacity increases for maybe you're scaling from 10,000 users to 20,000 users, right? It would help, right? But as your base grows substantially, right? When you're growing from maybe like 30,000 users to 200,000 users or to a million users, you typically transition to horizontal scaling. So you see, vertical scaling, horizontal scaling, it helps you to sort of get that difference. Now, when you start to horizontal scaling, like adding servers behind the load balancer to distribute that increasing traffic. And the truth is, most mature systems use both approaches strategically, right? Vertical scaling individual components, whilst horizontal scaling the overall thing, right? So when you think about these massive companies, they use both, right? They are sort of moving, they are horizontally scaling the overall thing, but then they are vertically scaling some individual components that might not be. So maybe something like login, maybe like authorization. Those authorization are not used every time. It's not as used as maybe like the streaming. Do you see what I'm saying? So those kind of things they might be vertically scaling it because it's a how many times do you log in and log out of your Netflix? If you think about it. It's probably you probably log in maybe once a year or twice a year on your Netflix, or probably you're logging in on another device. It's imperative that you have a situation where they might not, you might just probably be vertically scaling them because the use cases for those services might not be much. What is a load balancer? A load balancer simply is this tool that sits in front of multiple services and it just sort of like manages traffic. It manages incoming requests and evenly distributes them across different backend servers, right? So this load balancer, it prevents any single server from being overloaded whilst the others are probably idle, right? Um, so the load balancer in its algorithm sort of ranges from a simple Robin style where each server gets a request to sort of like a sophisticated um strategy where you sort of like have um we're looking at probably like you're considering the load, you're considering the response times, you're looking at the geographic proximity, you're looking at the session affinity requirements. And we'll sort of like talk about each of these different requirements because again, understanding load balancing is a key element of system design because I like to use the explanation of division of labor when it comes to load balancing. The concept of division of labor is that if I have 12 workers, right, and I'm trying to build, say, a I'm trying to build a house, right, and I have 12 workers, I'm not going to use all my 12 workers to build the gate, right? If I'm trying to get to where I want to get to, if I have a timeline, I'm going to put different people in different places to get things to move fast, right? Now, if you translate that same concept to system design, you think about it from the perspective of you have 10,000 users and 10,000 users are trying to log in into your application at the same time. Once the For them to log in, right, and for them to use the services behind the scenes, we need a load balancer that is going to distribute each of those requests that are coming into your system, and they're not going to one server because they will overload one server. If you're having 10,000 requests at the same time, if you have 5 servers behind the scenes, you want to distribute that load to 2,000 per server. Do you see what I'm saying? Right? So that sort of gives you a sense of what load balancing is. But then to sort of bring all of this together, right, there's a few things that I want to sort of mention here. Number one is having that even utilization for all the different servers behind the scenes. So whereby you are sort of keeping all your servers busy rather than some they are overwhelmed and the rest of them they are idle, right? Or some are doing more and the rest they are doing less. right? So you are maximizing your infrastructure efficiency. Number two point here I want to make is fault tolerance, right? If one server crashes, the load balancer is going to detect it immediately, right? Via those health checks that it's going to make, and it's going to stop all the routine traffic that should have been going there. Because and the truth is that your users will not notice because your load balancer is smart enough. It has these algorithms that it uses to notice these things, and it just basically starts to route your service to the right servers, right? Based off of the fact that you have noticed that one server is probably malfunctioning. The next point I want to make is scalability enabler. So I did mention early on whereby I was talking about horizontal scaling, where it's scaling out, and vertical scaling, where it's scaling up. Load balancing sort of is an enabler for horizontal scaling. So as you add your different servers to sort of scale out, the load balancer distributes the traffic across the different growing pool, right? It adds the capacity in a linear format to by sort of like adding different servers. And finally, it just helps you to have zero downtime in terms of updates. So where to explain this, whereby you're sort of removing servers one at a time, right? Whether that's for maintenance reasons or for you are making an upgrade to your system or you are deploying a new version, it simply just takes them one at a time and it wouldn't affect your user's experience, right? So it will take them the one at a time to do whatever it needs to do, and then it will return them back to the pool. The pool is essentially what you would see below here, whereby it sort of just shows the different backend systems. And at the end of the day, the most important thing is that for a user experience, there's no service interruption, right? Now, that's pretty much it how I want to sort of encapsulate what scalability looks like.